everyone. In this video, we are going to learn derivative of the implicit function. I will start with the definition of implicit function. Then I will explain what is the difference between implicit function and explicit function. Then we will derive the formula how to calculate the derivative of implicit function with the help of chain rule. And then we will figure out few examples. Starting with the implicit function definition. Implicit function is a relationship where one variable is not directly solved for, but instead is defined along with another variable in an equation. For example, we have x square plus y square is equal to 1. This type of a function is called as an implicit function. Here we have taken the two variable and it is not defined in terms of x or in terms of y, but they are represented in form of an equation. In general, we will say that a function of two variable is equal to 0. So we can convert this equation in this form by writing x square plus y square minus 1 is equal to 0. Although we can find the value of x and y in terms of other variable, but original form of this is implicit function. Whereas the explicit function is the one where the dependent variable is expressed directly in terms of independent variable. Means we are writing a y as a function of x. So we can write y is equal to twice of x plus 3. We have given that y is a dependent variable and in this case the independent variable is x. In the previous case, it is not mentioned whether x is an independent variable or y is an independent variable. Such type of a function is called as an implicit function. Moving towards the derivation of implicit function, suppose we have an implicit equation of this form fxy is equal to 0, where f is a function that is depending upon both the variable x and y. Now evaluate the derivative of this function with respect to x. For that, differentiate both sides with respect to x. So when you differentiate with respect to x, what we have, that is a derivative of a function with respect to x is equal to derivative of 0 with respect to x, that is 0. Now we will apply the chain rule. As per this function is depending upon two variable x and y. When we are taking a derivative with respect to x, it means y is a dependent variable and x is an independent variable. If y is a dependent variable means it is depending upon x. Now how to write the chain rule in this case? According to the chain rule, we will take the derivative of the function with respect to x, that will be the partial as it is depending upon two variable. So we write partial derivative of function with respect to x plus second is partial derivative of function with respect to y into derivative of y with respect to x. Now the derivative is only depending upon single variable, that is a simply dy by dx. This is equal to 0. This gives partial derivative of function with respect to y into dy by dx is equal to negative of partial derivative of function with respect to x. This further gives derivative of y with respect to x is equal to minus partial derivative of function with respect to x divided by partial derivative of function with respect to y. That is also written in this form, that function with a subscript x means partial derivative of function with respect to x, and here it is a partial derivative of function with respect to y. This gives you the formula for the derivative of y with respect to x is calculated as negative of the partial derivative with respect to x divided by the partial derivative with respect to y for the implicit function that is depending upon two variable x and y. Now consider we have the implicit function that is depending upon three variable x, y, z. Now we need to find the derivative of this function with respect to x. In this case, we will take the differentiate with respect to x on both sides, and we are getting this form because the derivative of 0 is equal to 0. Now in this case, a function is depending upon three variables x, y, z. We are saying find the derivative with respect to x. When you find the derivative with respect to x, means x acts as an independent variable, then y and z are the dependent variable. Now if they are dependent variable, maybe they are both depending upon x, or y is depending upon z and z is depending upon y. In this case, we need to find the derivative with respect to x. According to the chain rule, we have partial derivative of function with respect to x plus then partial derivative of function with respect to y, then y with respect to x, again it is a partial derivative, plus derivative of function with respect to z, then z with respect to x, is equal to 0. From here we can find the value of partial derivative of y with respect to x, that is equal to negative sign of partial derivative with respect to x, negative of this one divided by partial derivative of function with respect to y. Now suppose we need a partial derivative of y with respect to x, keeping z as a constant. In that case, z is a constant, and when you take its derivative with respect to x, this term is 0. If this term is 0, we have negative of partial derivative with respect to x divided by partial derivative with respect to y. In the previous case, we are getting a same formula. But in that case, we are not taking a z variable or third variable. Similarly, we can evaluate the partial derivative of z with respect to x in terms of partial derivative of y with respect to x. And when you find the partial derivative of z with respect to x, keeping y as a constant, we will get negative of partial derivative of function with respect to x divided by partial derivative of function with respect to z. Now we will conclude the derivative formulas for the implicit function. Case 1, when we have taken the function of two variable x and y. In this case, either we can calculate the derivative of y with respect to x or x with respect to y. This is calculated as negative sign of partial derivative of function with respect to x divided by partial derivative of function with respect to y. And if you want to calculate the derivative of x with respect to y, that is equal to negative of partial derivative with respect to y of the function divided by partial derivative of function with respect to x. From here you can observe that when we are calculating the derivative of y with respect to x, that is equal to partial derivative of function with respect to first denominator variable divided by partial derivative of function with respect to the numerator variable. In this case, we need a dx by dy. So x is in the numerator, we will take its partial derivative in a denominator, and y is in a denominator, we take partial derivative of function with respect to y in a numerator. But make sure it is a negative sign of this. Similarly, we can write the derivative formulas for the implicit function when it depends upon the three variable x, y and z. In this case, we can calculate these six types of derivatives keeping another variable as a constant. Like here we have taken the derivative of y with respect to x keeping z as a constant. In this case, z derivative with respect to x keeping y as a constant. And in that next case, partial derivative of z with respect to y keeping x as a constant. And the same procedure we have followed in this case, and we have these formulas. Now we will apply these formulas by using the examples. Using an implicit differentiation, obtain the following. The first case is find the derivative of y with respect to x when we have this function where alpha is a constant and x, y are greater than 0. First, we will write the function is equal to 0 form. So we can write in this case as x raised to power y plus y raised to power x minus alpha is equal to 0. Now we need to calculate the derivative of y with respect to x. That is calculated as negative of partial derivative of function with respect to x divided by partial derivative of function with respect to y. Now what is the partial derivative of function with respect to x? In this case, we will keep y as a constant. First term derivative with respect to x is y into x raised to power y minus 1 plus derivative of this term with respect to x. Now y is a constant. In this case, we will use this form. Derivative of a raised to power x is equal to a raised to power x log of a. According to this, we have y raised to power x log of y minus derivative of alpha with respect to x is 0 because alpha is a constant. Similarly, calculate the partial derivative of a function with respect to y. It means we will take x as a constant. In this case, x as a constant, we can use in the first case this formula to evaluate the derivative with respect to y. That is x raised to power y log of y plus derivative of y raised to power x, where x is a constant, that is x into y raised to power x minus 1. Now derivative of alpha with respect to y is 0. So we have function derivative with respect to x and y is equal to this. Substitute these values. We have negative of y times of x raised to power y minus 1 plus y raised to power x log of y divided by x raised to power y log of y plus x times of y raised to power x minus 1. This is the derivative of y with respect to x whenever we have this function. Moving towards the next example, we need to find the derivative of y with respect to x where the function is in this form. You can observe that this is already given as a function of x, y is equal to 0 as an implicit function. Before that, we need the derivative of cot inverse. Now, what is the derivative of cot inverse x with respect to x? That is equal to negative of 1 by 1 plus x square. Moving back to the question, we need a derivative of y with respect to x. This is calculated as negative of partial derivative of function with respect to x divided by partial derivative of function with respect to y. Now calculate the partial derivative of function with respect to x first. Take the derivative of cot, that is negative of 1 by 1 plus x square, and in this case x is replaced by x by y. So we have x by y square into derivative of the internal term with respect to x. So x derivative is 1 and y is a constant and it is in a multiplication. We will keep at y as it is. Plus derivative of y cube with respect to x is 0 because y is treated as a constant, plus derivative of 1 is 0. Simplify this, we have minus 1 upon y square plus x square divided by y square into 1 by y. That is equal to, this term is get cancelled with this one, negative of y divided by y square plus x square. Similarly, calculate the partial derivative of function with respect to y. Take its derivative with respect to y. We have negative of 1 divided by 1 plus xyy square into derivative of x by y with respect to y. So x is constant, we will take outside. Derivative of 1 by y is minus 1 upon y square. So we write in this case negative of x by y square plus derivative of y cube, that is a 3y square, plus derivative of 1, 0. Simplify this, we can write this term is equal to negative negative is a positive x by y square and the starting term is written as 1 upon y square plus x square divided by y square. So this y square is get cancelled with this one plus this 3y square as it is. Simplified form in this case is equal to x by y square plus x square plus 3y square. Substitute these values of partial derivative of function with respect to x and y in this case, and after that you will get the derivative of y with respect to x. Next is we need to find the partial derivative of z with respect to x keeping y as a constant, z with respect to y keeping x as a constant whenever we have the function of this form. First we will write the function is equal to 0 form, that is cos of xy plus cos of yz plus cos of zx minus 1 is equal to 0. Now, in order to calculate the first derivative, we can write this as equal to negative of partial derivative of function with respect to x divided by partial derivative of function with respect to z. In this case, this is equal to negative of partial derivative of function with respect to y divided by partial derivative of function with respect to z. Now calculate the partial derivative of function with respect to x, y and z. When you find the partial derivative of function with respect to x, in this case we will get minus sine of xy into internal derivative with respect to x, that is y, plus in this case that is derivative is 0 with respect to x because there is a no term of x and y and z are constant, plus derivative of cos zx with respect to x, that is the negative of sine zx into z, and the derivative of 1 is 0. Simplified form in this case is equal to minus y times of sine xy negative of z sine of zx. Similarly, calculate the partial derivative of function with respect to y and z. We have this. Now substitute partial derivative of function with respect to x, y and z in this case, and after that you will get the derivative of z with respect to x keeping y as a constant and derivative of z with respect to y keeping x as a constant. Now comment below what is the partial derivative of z with respect to x keeping y as a constant and what is the partial derivative of z with respect to y keeping x as constant for this implicit function.